All right, now we're going to talk about a different way of how to name compounds using what's called the E and Z designation. Okay, when you look at a double bond, there are 4 groups on your molecule. Okay, here's 1, here's 2, here's 3, here's 4. Okay, if you have non-hydrogen groups, you can either have a mono-substituted, a di-substituted, a tri or a tetra substituted double bond. This is for non-hydrogens. So I can have like a chlorine and 3 hydrogens. That would be a mono-substituted. I can have 2 chlorines. That would be a di-substituted. All right. I can even have the 2 chlorines. Have 2 chlorine here and a chlorine there and a hydrogen here. That would be a di-substituted. All right. Or I can have all chlorines all around the whole molecule. That would be a tetra substituted. Okay, so that's all that's meant by mono, di, tri, or substituted. If you have a di-substituted double bond, so if you have Cl, Cl, like that, all right, you use the cis and trans way of naming it. So this would be a trans. If you have tri or tetra substituted double bonds, you no longer use cis and trans. You use E and Z instead. I have no idea why they decided to do this. It makes no sense to me, but this is one of the rules. All right, where E stands for the trans and Z stands for the cis. Okay, so rather than saying cis and trans, they use E and Z only for tri and tetra substituted compounds. Okay, so now what we have to do is we have to learn the rules of how you do this. Okay, and it's not that hard. Okay, so let me put an example up here, and we will use the example to as our guide through the rules. Okay. So notice this is a tetra substituted double bond. Why is it tetra substituted? All 4 groups are different. Okay. So the first rule is, okay, look at groups attached to each carbon and rank based on an atomic number. Okay, so look at each group on each carbon and rank based on atomic number. So you have to look at each carbon. We have 1 carbon here and a second carbon here. So on this carbon, we have 2 groups. We have a chlorine and we have a bromine. Well, based on atomic numbers, which one of these has the higher atomic number? That would be the bromine. So if you look on the periodic table, bromine has a higher atomic number. Then you go to this carbon and you look at the 2 groups or 2 atoms that this carbon is attached to. One of them is a carbon and the other one is an oxygen. All right. Well, the oxygen has a higher atomic number than the carbon. You ignore everything else. You're just looking at the atoms directly attached to it. Well, the oxygen has a higher atomic number than carbon, so that gets the priority. All right. So now you look at the 2 groups and determine, are the 2 groups on the same side or the 2 groups on the opposite sides? Well, these 2 groups are on the same side. Therefore, this is the Z isomer. Okay. So it's based on atomic number. Don't do it on mass. I know it looks like, well, maybe it looks like it's based on mass. It's not really based on the mass. It's based on whichever one has a higher atomic number. Okay? So let me do another one. Actually, let's do this for practice. You guys can practice this. Alright, I'm going to pause it, or you can pause it, and why don't you work on the problem. Okay, so looking at this carbon, alright, this carbon first, carbon 1, carbon has priority over hydrogen, so that gets a priority. Then you look on the other carbon, carbon 2, chlorine gets a priority over carbon. So these are the trans, or the E is the appropriate one. So we can actually name this compound. I'm going to show you how to name this compound. Okay. longest continuous chain that includes a double bond, close, and then you start at the end closest to the nearest substituent. So this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4. Okay, you no longer use the 1 and 2 like I was showing you. That was just to determine E and Z. This is now your naming rules. So you have a chlorine on carbon 2, so 2-chloro, and this is a bute. So, I'm sorry, you have to put E, usually put in parentheses, I left that out, that's the important part. E2-chloro, butene. Okay? For practice, why don't you draw the Z2-chloro butene. Alright, so the way this is going to look is you just switch one of the groups. You just switch one of them. So I keep that the same, but let's put the chlorine down here and put the methyl. And that would be the Z, because carbon still gets priority over hydrogen, and chlorine still gets priority over C, but notice we switch the groups. So that would be the Z. Okay? Now, the second rule is, what if you have a tie? If you have a tie, look at the 3 atoms attached to the same atom and determine which one has a higher atomic number. Okay, so what happens if you have a tie? Let's see what happens. You always have to look at the 3 atoms that it's attached to. Okay, so let's look at this carbon first. That's attached to a carbon and a hydrogen. Carbon wins, so this gets the priority. Okay, there's no tie. There's nothing special there. Let's look at the next carbon. Notice this carbon's attached to a carbon, and it's attached to another carbon. So we have a tie. Obviously, neither one of them has a higher atomic number because they have a tie. So what you do is you look at the 3 atoms that these atoms are now attached to. So that's what I'm trying to say here. If you have a tie, look at the 3 atoms attached to the same atom and determine which one has the higher atomic number. The same atom meaning this carbon and this carbon are the same. So what are the 3 things these atoms are attached to? Okay? All right. So this carbon is attached to a hydrogen, and another carbon. So a hydrogen, and a carbon. This carbon is attached to a hydrogen, and a hydrogen. So basically what you do is you look for the one that has the higher atomic number. All right, well, these are equal. So those, I mean, if you want to cancel them out and just ignore them, that's fine. All right, equal ones you just basically ignore. Well, we have a carbon compared to a hydrogen. Obviously, this carbon beats out this hydrogen, so that means this is the priority. So this would be the E isomer. All right, for practice, why don't you name this compound? Put it on pause and name the compound. All right, what you should get is, this is carbon 1, 2, 3, 4, 5. So you should get E, 3-methyl pentuene. All right? Now what happens if you, so, you know what, let's do another one. Let's do another practice problem. Let's see. It's going to look a little weird, but, you know, obviously there is a reason for this. All right, see if you can determine the E and Z on this one. I'll put it on pause. Why don't you put it on pause and practice? All right, so let's go through this. So in this carbon, look at the two things it's attached to. It's attached to a chlorine, and it's attached to a carbon. Carbon versus chlorine. Chlorine gets the priority. If you circled the carbon with the 3 bromines, that's incorrect. Okay? Because you're not looking at atomic weight. You're looking at the atoms that are directly attached. The bromines are not attached. They do not count in the prioritization. It's the carbon versus the chlorine. Over to the right, the oxygen gets the priority over the methyl. Okay? So this will be an E isomer, trans. This priority and this priority. Okay? Now, what happens if you have multiple bonds? What if you have a triple bond or double bond to oxygens? All right, what happens? So let me show you. I'll give you an example. Like what if you have a carbon? Let's say you have an aldehyde group. Okay. So you have so on the left side, fluorine gets the priority. On the right side, you have a carbon. Right, this carbon is attached to this one, and this carbon is attached to this carbon. Well, you have a tie. So what do? You look at the next atoms. Now, when you have a multiple bond, count that many atoms, however many bonds you have. Okay? So this carbon is attached to a hydrogen. It's also attached to an oxygen, and it's attached to another oxygen. You always have to have 3 things. So if you have a double bond, count it twice. If you have a triple bond, count it 3 times. This carbon is attached to 3 hydrogens. Obviously, these hydrogens can cancel out. Oxygen have higher atomic numbers than your hydrogens, so this will get the priority. So you have an E. Again, seem to have E quite a bit here. Okay? So, look at the homework, do the practice problems. There's a lot of other possibilities, but pretty much these are the rules. You just keep going until you have a difference. If you keep going and you don't have a difference, then you don't have E or Z. All right? The molecule will not have a cis or trans conformation to it. Let me just give you an example. Like let's say we have a CH2, CH3, CH2, CH3, and let's say we have a hydrogen and a fluorine. Okay, on the left side, the fluorine gets a priority, but notice on the right side, these are the exact same groups. There is not priority. So because of that, there is no E or Z. All right, just because you have a double bond doesn't mean you have an E or Z. You have to have 2 stereoisomers of that molecule, meaning there has to be 2 possible ways of drawing it, and they differ in 3 dimensions. If I were to switch these 2 groups, it'd be the exact same molecule. Nothing would be different. Even if I switch the H and the F, it'd be the exact same molecule. Okay? So these groups here have to be different.